another thing we want our script to be able to do is have the player character turn as it's moving around. As you can see, currently, as it moves, it still sort of stays statically facing the same direction. So it would be nice, let me scale this cube a little bit to exaggerate the direction it's facing. It would be nice if this pointed the direction it was moving, which would give the impression that it had turned to face that direction. Back in the player control script, I'm going to space this out a little, make it easier to read. I'm going to add another method here to reference the rotation of the object. Now, the rotation is encapsulated inside the transform category. If I refer to it like so, transform.rotation, that is the rotation of the object. Now, the method I'm going to use to calculate which direction it should be facing is called look rotation. Look rotation takes a vector 3 and sort of figures out what direction an object would have to turn to be facing that vector. And in this case, I can very fortunately use the same vector as the movement, as the input that I had determined earlier. And this way, when somebody is pressing up and to the right, the vector is up and to the right. So the player object should be facing that same direction. And fortunately, that makes my work a lot easier. I don't have to declare anything different. If we try to play this right now, let's see what happens. Wait a moment for the script to compile. So now, as it moves around, well, it certainly does turn to face the direction I'm looking. Well, not quite, actually. I'm facing forward right now. It causes some pretty strange things to happen to the way movement works, although it is definitely rotating as it goes. So, it's clearly something has to be corrected here. So what's happening is every time it translates now, it's doing it in object space. And an easy way for me to fix this is to put it in the space of a different object. In this case, I think I can probably just use the camera. So what I need to do is create a reference to an external object and then plug the camera into that reference. In order to make it editable in Unity's interface, I will declare it as public. This is going to be a game object variable, GAME, and for the sake of simplicity, let's just call it a camera. Now, in the translate method, if I define camera as an additional variable, my mistake. I should not be using the variable type of game object. I should be using the variable type of transform. Now, if transform is used as a second argument to the translate method, then it determines the space within which this vector 3 is being applied to the object. So with that in place, hopefully the rotation of the object no longer has that effect on the way the translate method updates the movement. And in fact it does not. Now I can go around in a figure 8 type pattern and it always faces the direction that that is being pressed. However, when I stop pressing anything, it begins looking straight forward, and when I change directions suddenly, sometimes the behavior is not ideal, like when it turns 180 degrees, it kind of snaps, and that doesn't look quite right. So I need to make a few more updates to the script. So first of all, I'm going to add a variable much like move speed to control the speed with which the player can turn. Let me call it turn speed, and this will allow the scene creator to dial in a number that better fits their version of how quickly a character should turn around. To control the speed with which the rotation is applied, I'm going to kind of split this apart. I'm going to assign transform.rotation in a statement separately from this action here. I will save the direction that the player should be facing, in a new quaternion called turn goal. Let's call it. So quaternion turn goal equals new quaternion, and actually, yeah, I don't need to make a new quaternion. Turn goal will equal this method that we were using before, and here I will use another method from the quaternion class. This quaternion contains a slurp method. Now, this isn't necessarily the correct way to implement slurp, but I think it works fine for what we're doing today. Slurp is a linear interpolation, that's what lerp stands for, between two variables. So it goes A, then B, and then a third argument, which roughly is how quickly the interpolation takes place, and the S is at the beginning of that because it's a smooth linear interpolation. So for the speed variable, I already know that I'm going to want to reference time.delta time, so that it will update predictably based on the frame rate of the application. And this is also a good place for me to plug in this modifiable variable, the turn speed. So how about I multiply the two right here, and what I'm interpolating between is whatever the rotation of the object is, and what I want the rotation to be, which is the turn goal that I defined in the previous statement. Alright, now that should sort of slowly move between the two, and it also has a number in place for the turn goal, or I'm sorry, the turn speed, which will let me decide how quickly I want that change to take place. So with a value of 1, it is obviously way too slow. Oh, and another thing I never fixed is when the movement stops, it always goes back to 0. That's of course because the input equals 0. The vector 3 for input equals 0 when I'm not holding any keys, because it equals get axis horizontal and get axis vertical. When no keys are pressed, both of those values zero out. So first, let me find the right number for turning and see what feels good. This is still really fast, but it's better. I can definitely, it definitely responds quickly, but still gives me the impression. It gives me enough time to see what's going on. Maybe 10 is a good idea for there. Let me put 10 back in. And in order to prevent it from facing forward again, like it's doing, I'm going to put this entire method in. I'm going to put everything that's contained in the fixed update method into a different method, and have that method only update when a key is held down. So to declare a new method, I have to write some code outside the brackets of any other method. I'm going to call my method move, and a method, a method declaration. I just want this to be called move. Tooltip was kind of forcing me to call a different variable right there. So naming a method looks like this. The name of the method, and there's also the return type of the method. So this method isn't going to return any type. We'll just call it void. And then inside fixed update, I'm going to call the move method, and calling it looks like this. Now if I just paste, whoops, how about I copy all this before I delete it, and now back to here. If I paste all of that code that was in the update method before, this is effectively the exact same thing as it was a second ago, but it allows me to put a limit on when move is being done, and I'm going to do that in the form of an if statement. Now what I want to do is have move only run if the vector 3 of direction isn't 0. So because of that reason, I decided that I want to declare that outside of the method. But now that I've done that, vector 3 direction has been declared here, and it's outside the scope of the move method. This direction variable only exists in fixed update. So to get around that, I will actually change the place that direction is declared up here. Here I will call it a private vector 3 direction, and I won't assign it here. It's uninitialized. That means I can initialize it down here and refer to it within the move method. And because its definition exists within fixed update, I can use it to qualify the if statement. If direction is not equal to, there's a variable within the vector3 class called vector3 something. Let me check my other script really quick. That method is called vector3.0. So now this little exclamation point means not equal to. If it were double equals, that means, sorry, if it were double equals, that would mean equal to. If direction is equal to 0, then updates this method. Of course, that's the opposite of what I want. I want it to only update when vector3, when direction is not 0, when it's not nothing. Whenever this if statement evaluates as true, it will execute the statement immediately following it. Just for the sake of clarity, I'm gonna throw move into brackets so that now whenever if executes, it will do everything between these two brackets. Let's see if that fixed our problem. Once the script compiles, I will start playing the application. And now it's doing what I want it to do. The behavior that I wanted was that it will face the direction that we're pushing in, and it stays facing that way even when we let go of the keys. Perfect. And that will work with a controller also, because I used the names of these axes instead of the names of keys. No keys were referenced anywhere here. So if I ever decided I wanted to change what those axes refer to, all I would have to do is open up the input manager from the project settings. So thanks for watching. That's a very basic character control, and we'll explore more with putting animations with that in the next video.